This is the recording for Chapter 8.1, classifying polygons as concave, convex, regular, and not regular. Your assignment, your paper will be folded in half vertically because your assignment, pages 413, guided practice 1 through 9, that's one of your assignment, and pages 413 through 414, 10 through 24 will go on the right-hand side. Your notes will go on the left-hand side. On page 411, you have some definitions and some examples. A convex polygon says, if you extend the sides and none pass through the interior of the polygon. So let's see what that looks like on letter B. So look at letter B in example 1. Theirs is a nicer pentagon than mine, but you'll have to deal with mine. So if I take and extend these sides, that doesn't go through the center of the polygon or the inside. This side extended does not go through the inside. This side extended does not go through the inside, nor does this, nor does this. So when one extends the sides, the segments of the polygon, none of them will pass through the interior of the polygon. Now in a concave polygon, so that was convex that we just did, that pentagon. In a concave polygon, if I do the same thing, what you'll see is the extension of those segments, the lines that you create, will pass through the interior of the polygon. And so that one's fine, and this one is fine. Doesn't pass through the interior. This one's fine, and this one's fine. Doesn't pass through the interior. But as soon as we get here, we start seeing that they're passing through the interior. It just takes one passing through the interior for us to know that, in fact, this is a concave polygon. Now, personally, I don't do that. I just look at them. If it's got this little, let's use a smaller one. So if it's got this little spot right here where it goes in, I already know it's a concave. That's how I look at it. But the formal definition is if you extend the lines and they go through the interior of the polygon, it'll be concave. All right, now, knowing that vocabulary is important to what you're going to be doing later on, so please refer to it if you need to. As we look down at what we're going to do now is we're going to look at the page 412 examples. So if you turn to page 412, we're going to look at examples A, B, and C. And we're going to talk about, at the top of the page, the 3 types of classifications. You can have an equilateral polygon, an equiangular polygon, and a regular polygon. And in an equilateral polygon, all sides are congruent. In an equiangular polygon, equa means equal, all angles will be congruent. And in a regular polygon, all angles and all sides will be congruent, meaning that it is equiangular, equilateral, and equiangular. So it is equilateral and equiangular. Now, with that said, as we look at the A, B, and C, let's sort them. So you can see on A, all the angles are congruent, and it almost looks like all the sides are congruent, except at the very top you can see the double tick marks. So those are going to be all angles congruent. We put that in there. For letter B, you can see that all angles and all sides are congruent, so it goes in the regular polygon. So B goes in the regular polygon. If you draw those figures in there, that would be great. And letter C is a heptagon. It's 7-sided. You can see that the only thing we know about are the sides, and those are congruent. So please place that heptagon inside. All sides are congruent. That makes it an equilateral polygon. Now, a really common equiangular polygon that we're familiar with is a rectangle, so we're going to draw that as well. So in a rectangle, there will be these 2 sides congruent and these 2 sides congruent. So all 4 sides are not congruent, so it would only be the angles that are all congruent. So if you have a square, it's in the regular polygon category, but for just a rectangle, it's going to be an equiangular, all right angles polygon. So I thought we'd put it in there just so we have it. All right, now we're going to go ahead and classify these 4 figures, excuse me, as to whether they are concave or convex as well. The directions don't ask for that, but we may as well do it. So on this one, I'm going to tell you that as I see this, there's this little chunk that goes in. I know that that's going to be concave. So this one is concave. And if I were to extend that line, you would see that it went through the inside of that polygon. Now I go to the rectangle, and that one's convex, because if I were to extend these lines, any of them, you would see that it never passes through the inside of the polygon. And the same holds true, I'm not going to do it on this one, but if you extended any of these sides on this octagon for A, you would see that none of them would go through the inside, so this is also convex. On this pentagon that's a regular pentagon, it's a five-sided figure. If I extend the lines, none of them will pass through the inside. This is a smaller figure, so I'm going to go ahead and do that. So if I extend that line, not passing through the center, extending that line, not passing through the center. So you can see that on all of these, if you extend the segments on all of these, they won't pass through the center of the polygon, so it's convex. Again, you have to use that classification as well as classifying it as equilateral, equiangular, or regular. So you may as well practice it. Okay, we're moving on to the next page. Okay, continuing on with chapter 8.1, classification of polygons. This is checkpoint activity on page 412. There's 1, 2, and 3. I would ask that you would draw those figures, and as soon as you, or go ahead and pause the video, then draw the figures, then turn it back on, and we'll go ahead and do number 1 together. Okay, now that your figures are drawn, let's look at the directions. The directions for 1 through 3 on page 412 say, decide whether the polygon is convex or concave. So the first thing you have to decide is whether it's convex or concave. So if we were to extend these lines out, it would not go through the center. Extend that segment out, not go through the center. Extend this segment out, it won't go through the center. And if I were to extend this segment, it would not go through the center of the polygon or the inside of the polygon. So therefore, this is going to be convex. And then the next part of it says, then decide whether the polygon is regular. So either going to write regular or not regular, and then it says explain your reasoning. And so this one is not regular. And the reason it's not regular, even though the sides are all congruent, you can see that the angles are not. These two angles are congruent and these two angles are congruent to one another. So it's not regular because it is equilateral, but not equiangular. Has to be both to be regular. So go ahead and determine the number 2. So first convex, concave, and then your second thing is regular or not regular, why? And convex, concave, and then regular or not regular, and why? Okay, once you've completed that, go ahead and turn it on, the recording back on, and listen to what the solutions were. Okay, on number 1, we've already done all of that. Let's go to number 2. And it's going to be concave, and let me just explain to you how I look at it. This little part here is caved in, so I know it's concave, but the way the book talks about it is if at any point you extend one of the segments and it goes through the inside of the polygon, then it's going to be concave. So you can see it happens here, and it also happens here as well. You don't have to have it happen in more than one place, though. On number 3, it's not regular, because although it's equilateral, it is not equiangular. Now looking at number 3, this one's convex, because if we were to extend any of these sides, these segments, you would see that you're never going to pass through the inside or the interior of the polygon, so it is convex. It is also a regular polygon because you have 4 right angles, which means they're all congruent, so it's equiangular, and you have 4 congruent sides, so it is equilateral. It's actually a square, so squares are regular polygons. Now, let's go back up to the first page and remind you of what your assignment is. Again, it's 2 assignments. We did the first part in class, so if you were absent, then you will need to get that done. And then the second part was homework. So page 413, guided practice 1 through 9, was done in class together with your table mates. And then for homework, you had pages 413 to 414, 10 through 24. Again, do this all on the same page. It's 2 assignments, but please do it all on the same page and do it on the right-hand side of the paper so that you have your notes to look at.